using inequalities in a triangle. And we are also going to work on lesson 5-6, inequalities in two triangles. We will not be doing indirect proof. So the first thing we want to do is make sure that we can solve, go back and solve some of these problems. You should be able to do these. So just to check your answers here. X is less than 7, and x is greater than -12. Hopefully you got those right. Ooh, this one is much longer. Let's do this one. 2x minus 2 is less than 3x minus 4 plus x minus 8. So 2x minus 2 is less than 3x, and x is 4x. -4 minus 8 is -12. I'm going to subtract 2x from both sides. I'm going to add 12 to both sides. And I get x. 5 is less than x. Or if I rewrote it, so that's how they have it. They have the variable on the left. X is greater than 5 is the same as 5 is less than x. Find all of the integer solutions for this. So those integer solutions would be 5, 6, 7, 8, 9, and 10. Let's see if I'm correct. That one, and I am correct. So for our first example, we're going to talk about side lengths and angle measure. If you draw an obtuse scaling triangle, you can find the largest angle and the small side and mark them in red. So if I draw an obtuse scaling angle, you'll see that the longest side, as marked in red, is across from the largest angle. And you will also see that the shortest side is opposite the smallest of the angles. That's no accident. That's going to lead us to our theorems about triangle inequality. If one side of a triangle is longer than the other side, so here I have side AB is longer. I want to change that color. Is longer than side BC. And the angle opposite the longer side, so this angle here, is going to be larger than the angle opposite the shorter side. Okay? And theorem 511 says that if one angle of a triangle is larger, so for instance, angle 50 is larger than angle 30, 50-degree angle is larger than the 30-degree angle, then the side opposite the larger angle is going to be longer than the side opposite the smaller angle. So I've color-coded it to help, but what we're saying in this first theorem is AB talks about the side length, and AB is longer than BC. So the angle opposite AB, which is angle C, is going to be greater in measure than the angle opposite side BC, which is angle A. Okay? In theorem 511, we talk about the angles first and then the side measure. So if the angle A is 50 degrees and that measure is greater than the measure of angle C, which is 30 degrees, then the side opposite A, which is side BC, is going to be greater than the side opposite than AB, which is opposite angle C. test practice. You are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is about 27 feet long, and the left slope is about 24 feet long, and the right slope is about 20 feet long. So we have this down here. Okay. You are told that one of the angles is about 46 and one is about 59. So you know that the 46 has to be here in the bottom left-hand corner, and the 59 has to be here in the bottom right-hand corner, because 20 is smaller than 25, so the 46 has to be across from the smaller number. So the angle measure of the peak, you start at 180, subtract 46, subtract 59, and you get 75. That is the correct answer. Okay, just took a look at those few lessons that we did. We should be able to list these in order. The smallest side is going to be side ST because it is across from angle R, which is 29 degrees. Then RS, because it is across from angle T, which is 30 degrees. And then side RT, because it is across from the longest angle, which is 121 degrees. And I am correct. Second problem, we have a stage prop. Okay, so you can read all this, read it. And I'm going to kind of draw a figure here. They want to sketch and label a diagram. The shortest side is on the bottom. The right angle is on the left. So that's 90. That means the largest side is across from it, it's 10. They want the shortest side on the bottom. The shortest is 6, and that would have to be across from the smallest angle, which is 37. And then the last one would be 53. It's kind of hard to see, but that is correct. Okay, it's a very sad moment when you find out that not all triangles work. Not every group of 3 segments can be used to form a triangle. The lengths of the segments must fit a certain relationship. For example, the 3 attempted triangle constructions below are shown below. Only the first set of lengths makes a triangle. You can try this at home. You can cut a straw 2 inches, another one that's 2 inches, and one that's 5 inches, and you will find out that you will not be able to make a triangle. It all comes down to this. There is a triangle inequality theorem. Basically, the sum of the lengths of any 2 sides of a triangle has to be greater than the length of the third side. So for instance, AB plus BC has to be greater than AC. This comes from the concept that the shortest distance between 2 points is a straight line. So if you're going from A to C around the corner, it has to be longer than AC itself. The same thing is true if I try to go AC, and CB has to be longer than AB. And AB plus AC would have to be longer than BC. So you can find all possible side lengths. If a triangle has one side length of 12 and the other side length of 8, describe all of the possible length combinations. So they go through this whole solution where X represents the length of the third side. Draw diagrams to help you visualize the small and the large value of X. And then use the triangle inequality theorem. So I'm going to help you here so that you can visualize this. So basically, if I take these 12 and 8, and the smallest side would have to be, X has to be greater than 4. If X is less than 4, 4 plus 8 is going to be less than 12, and that's not going to work. And then also, X could be the largest size, where 8 plus 12 would have to be less than 20. So basically what I think of is take the two sides, add the two sides, the final answer has to be less than that. And if you subtract the two sides, x would have to be greater than that. So let's try that. Triangle 1 has a side length of 11 and a side length of 15. 11 minus 15 is 4. I don't know what happened there. Having some pen difficulties. It's 4. And 11 plus 15 is 26. So x has to be somewhere greater than 4 and somewhere less than 26. Are you ready for the daily homework quiz? So they want us to list the sides in order from least to greatest. The smallest angle here is 50 degrees. So the side opposite is going to be the smallest. Then next is the 60-degree angle, so the side opposite it. And the last one, so the side opposite. And we are correct. Okay, now they want us to list the angles. The smallest side is 25. So the angle opposite it, angle R, is going to be the smallest. Then the next smallest side is 30. So the angle opposite it. And the last one is 46. So the angle opposite it. Tell whether the side lengths can form a triangle. Well, the two shortest, 35 and 18, add up to more than 37. So the answer is yes. 3 plus 3 is not more than 6. So the answer is no. And the last question, Jeremy wants to build a triangular toy using sticks. He has one stick that is 12 inches, another is shorter as 10. What are the possible lengths of the third side? Well, 12 minus 10 is 2. So his next side length has to be greater than 2 and less than 22. And here, if you want, you can look through the problems. We are not at this time going to do indirect proof. I know how disappointed you guys are that we are not doing it. So, talking about, I think I mentioned this at the beginning of the chapter, that you're going to learn about the Hinge Theorem. So imagine a gate between fence posts A and B that has hinges and A and swings open at B. As the gate swings open, you can think of a triangle with side AC formed by the gate itself, side AB representing the distance between the fence post, and side BC representing the opening between post B and the outer edge of the gate. Okay? Notice that as the gate opens wide, both the measurement of A, so this angle here is going to get wider, and this distance here is going to increase. This is what gives us the Hinge Theorem. So the Hinge Theorem, and you will see how it is related to what we were talking about with triangle inequalities. If two sides of one triangle are congruent to two sides of another triangle, okay, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So we're starting to move here away obviously from just straight triangle congruence, where we would have expected to find this third side the same. It's not. Here we have this hinge, and as this opens, as this two sides of the angle kind of open, the third side would get larger. The converse of that is that if two sides of one triangle are congruent to two sides of another triangle, and the third side is longer than the first side, then the included angle of the first is larger than the included angle of the second. So to recap on Hinge theorem, the Hinge theorem itself talks about the angle where you have an angle measurement and you want to compare side lengths. The converse is you have side lengths and you want to compare angle measurement. And of course, we're going to now use this in a few different problems. So given ST is congruent to PR, how does PST compare to SPR? So PST and SPR. So this side and this side are congruent. These are congruent. The third side is not congruent, but because PT is longer, angle S will be greater. So they have it written down here. Measure of angle PST will be greater than the measure of angle SPR. Okay, we're also going to solve a multi-step problem. Two groups of bikers leave the same camp, headed in opposite directions. Each group goes 2 miles, then changes directions and goes 1.2 miles. Group A starts due east and then turns 45 degrees north, as shown. Group B starts due west and then turns 30 degrees south. Okay? Which group is farther from camp? And explain your reasoning. So to help you out here, they have a diagram drawn here. So they draw a diagram and mark the given measures, the distance biked and the distance back to camp from two triangles with congruent 2-mile sides. So this is congruent to this. And then they each did 1.2 miles. So they drove 2 miles and then 1.2 miles. Okay, so next use linear pairs to find and mark the included angles of 150 and 135. Okay, the reason this is 135 here is because this was where they said was 45. So 135 plus 45 is 180. This is 150 here because when they said they turned 30, this is the 30-degree angle. So this is 150, okay? So these, okay, are congruent. Let me also mark this. Those are congruent. Okay, the 1.2 is congruent. In fact, that in red also is. So the 2 miles are congruent. The 1.2 miles are congruent. This is 150. This is 135. So this segment is longer. So group B is farther from camp. Okay, so for the first valued practice problem, you can read the problem. They tell us that these are congruent. They tell us that QPR is greater than QPS. So the side opposite QPR is going to be longer. Okay, next problem. They tell us that PR is congruent to PS, RQ is longer than SQ, sorry, RQ is shorter than SQ. So SPQ must be longer. Right. And then this next one, they talk about the camps again. So I want to go back, look at this. I'm actually going to take a clip of this so that I can use this in this slide here. Rather than going back and forth, it'll be a little bit easier to see this. Okay, so if you remember, group A went 2 miles to the east, then they turned, I think it was 35 degrees, but this angle here became 135. For here, they went 2 miles to the west, and then they turned down 30-degree angle, that left 150 degrees in here. So this next one, they're basically going to go up 2 miles, and then they're going to turn 40 degrees. Actually, if they're going to turn 40 degrees, this is not to scale. Okay, but they're going to turn that way. Okay, so this is 40. It's hard to see this here, but this is going to be 140 in here. So the moral of the story is the 140 is in between the 150 and the 135. Group B is still going to be the furthest here from camp, followed by group C, and then by group A, which is still the closest. And here are the 2 questions going over what we've done in this part of lesson 5-6. So KL compared to NP. So 2 sides are congruent on these triangles. The angle opposite KL is 75. The angle opposite NP is 80. Since 80 is greater than 75, NP is greater than KF. So measure of angle 1, that's across from 12. Measure of angle 2 is across from 22. So 22 is greater than the measure of angle 12. You need to look at the pages out of the textbook for the homework questions. There they are.